Okay, let's make Terry Winograd proud. Let's
Okay,
make
let's make
Terry...
Terry Winograd proud.
Good. Okay, that was a bit of a stumbling start. Here's Terry Winograd. What a man. The inventor of this Winograd scheme that I'm trying to tackle. And look who his students are. Some well-known names. I ordered an Anki Vector, the super cute little robot. It's going to be there on Tuesday or Wednesday. I could have ordered from Amazon, then it would be here tomorrow, I guess. So 3 days earlier. Why does Amazon do that? 1 day delivery. Anyway, Anki Vector has Alexa built in, so I can compare Alexa to my own assistants.
My own assistants.
Okay, back to Winograd. Where are we at? For example, we need to turn words into variables. He thinks that he and him are buddies. Reasonable sentence. And the two different occurrences of he should be replaced with different variables. 1, 2, 3, whatever. And I made a function for that. Then I made some more patterns. They can basically be as many patterns as we want, but they need to be in a priority sort of list. Meaning that patterns that are currently useful are on top of the list. So you could theoretically apply 1,000 different patterns, but the first ones you try are going to help you out because they are known to be useful. And if a pattern doesn't, well, actually, if one of these patterns does not relate to any rules, you will probably want to skip it because you only need the pattern for applying a rule. I also made a list of rules here, and these are typical things. Here is the rule that says how a question is answered. Who is funny? Conan O'Brien is funny. Answer Conan O'Brien. You couldn't say that he tried really hard. He tried really hard is not true, first transformation. And then the second rule applies. And we find out that the person didn't try very hard. And these are all like the different ways of saying the same thing, but they trigger different rules. So we need these rewritings. Generally, with the parsing, I've gone away from the idea of having a general parser for English. One parser for everything. It's still one parser, but the point is that one sentence can be parsed differently. For example, you could do really small steps, take the full sentence and split one word off at a time, make a complex structure. Or you can have longer patterns. For example, here, you gave her a gift or something. A gift is just hard-coded in the pattern. In a normal grammar for English or such, you would not do this. You would always say noun and verb phrase, and as a part of the verb phrase in there, there's another object, another noun, and that's a gift, and a gift splits into a and gift. But this is just so much faster. It doesn't hurt to have an additional pattern that's almost, that requires one step only. He gave her a gift, and this pattern is applied, and you are done. The parsing is done. Let's try that just right now. Yeah, we already have it here. George gave Paul a gift. One pattern matches with 2 arguments, that's it. And this is super clean and simple parse. So even on the smallest machine, like when we port this to Arduino's smallest devices, then this is going to be very fast. If you use a full English parser, I'm not sure if this would fit on a small embedded device. Because in this complicated sentence we have wrong parsers too. But it becomes clear quickly. If we apply this Python pattern first, we get this sub expression. George gave Paul a gift because he, and this will not match any further probably, or not in useful ways, because it's not a real sentence. So this branch of the tree kind of dies quickly. And the better branch, which is this one here, will be explored. All right. Okay, so let's say we have a parse. Let's do something that we have rules for. You couldn't George tried something like that. But you couldn't here it's subtly different. Let's add another one. You couldn't say okay. But you couldn't say with he tried very hard. Yeah, so the path from the root to this here is the good parse. Okay, that wasn't precisely true, but George tried. Okay. And let's add another one here. You couldn't say that. So this here should trigger all these rules. So how do we get this parse tree into the logic engine, which applies the rules? These are the groupings, I call that groupings. From this parse tree, the parser makes bracketed versions of the input. Again, like in the tree below, some of these are not good and some are good. Yep, it's all working. Down here we have the original input without any grouping. You couldn't say he tried very hard. I think this one should help us. Let's open the so-called playground, which is where you can test the logic engine. Here's already a simple example. If these are the facts, A is tired, B is awake, you ask who is tired, then the answer is A. The answer is also who, for technical reasons. You have to filter these results to get the one that you're interested in. These basic rules, like this one up here, they always need some fine-tuning. They will always grow a list of conditions, examples, counterexamples, to flesh out this rule. That's a very important concept. So there should be a feedback button here where you can say, okay, this is the one I wanted, this not so much. So it will be fed back into this rule somewhere. Just the framework for that isn't there yet. I have to build all my own databases, so I would like to outsource this to a database programmer. Anyway, okay, let's say take, which one do we want? 0, 1, 2, 3. Take number 3. And copy to clipboard. And paste. Okay. Facts deduced, none. Then let's say we put in the rule. Kind of want all of these, right? Oh yeah, that should be a thing. That should be a thing. I think we kind of have it. We have item set. I want a button to export as text. And we want to pop it out. So a button on the left, clear, add, copy to clipboard. Let's do the original order, right? Copy text to clipboard. List. Yeah, product name. Lines. Oop. That could be that. Or not. Oh, I did some really stupid bug, I'm sure. It has to be a bracket error. Yep. Kind of ate some of the brackets. Yes. Oh, these are my lucky days. I found a 6-pack of the favorite iced tea. I have sparkling, and it was on sale. My favorite iced tea and an Anki vector. I am getting good things. So are we doing something, dear computer? Oh, it's reloading all the modules, okay. Yes, copy to clipboard. Find the module. Paste. You will notice that as soon as I change a character, it recalculates the results. We need a rule for this but thing. I don't know what you think, just A but B means actually A and B. We could, in fact, No, let's do this first. And then we have another rule which says A and B, and we unpack this, what do you call it, two things combined with and. It's an enumeration. We unpack this enumeration. You will see why in a moment. We need to bring things to the top level, if you will. Now I thought something would happen, but nothing happened. Maybe my rules aren't working like this. I'm not sure anymore. Okay. Yeah, that should be improved, I guess. It has to guess where the rule begins and ends. So you need spaces in between. And now we have output. Remember, this is the original input. And we get George tried, which is the true statement. And you get he tried very hard is not true, and you get he didn't try hard. Wait, no, one step is missing. Okay, we need a duplicate button here. Let's say we make a more general version. Tried $hard. $hard. So this means it's now a variable, it can be something else. So hard will be very hard in this case. And let's fix this copy to clipboard thing for our purposes. Copy to clipboard with as paragraphs. Join with empty lines. Fix the brackets. Sorry. And drink some tea. Boom, 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 boom. Here, copy to clipboard as paragraphs. And overwrite. Oops, where? Tried very hard is not true. Yeah, we should, yeah, okay. Oh. Yes, he didn't try very hard. Yes, that's the one. Yeah, so the input was, what was the input? George tried, but you couldn't say he tried very hard without the brackets, because the brackets will be added automatically. And the result is he didn't try very hard, which is a good fact to deduce. Fact with the bracketing problem. Okay. Find the right here. These, oh, come on. These are all the groupings, which are 6 that are coming out of the parser. We want one more, I think. namely tried should already have reparsed, so now nope. Wait. What? Yeah. Okay, I think the update didn't work. I actually was very proud that when I added a pattern here, that the parser notices this and automatically reparses. I think it didn't do it this time. Unknown reasons. Okay, now we get more. There can be this pattern explosion if you have many patterns, as I said before. But one of these is going to help us more than the others. We could try to automate this, just what I did manually here right now. Take all these different groupings and run the logic engine on each of those. See what comes out and kind of notice how often certain facts come out. Yeah, just automate this step because we have this multi-stage approach. And it's not even actually in there, I think. I took a different route right now. Okay, it doesn't matter, but let's automate that. Here. Run logic engine on all parsers and rules in context. Yes. Why is my chat so empty? Oh my god. I think you have to pre-produce, if you start a channel and stuff, you have to pre-produce content, which is difficult because it's way, way, way easier to make good content and to be motivated when people are actually watching. If they watch later, or if you only have to assume that people will watch something, at some point you have to kind of build up like a fake motivation. I mean, not fake, but find the motivation in yourself, or have a strong faith in that content will be interesting. Do you understand what I'm saying? Getting started is not trivial. Okay, let's try this automation. Just a very nice parser. 110 lines, but packed with functionality. All groupings. Just a convenience function. All groupings. Try that. Yes. For grouping in a list of strings. And if I use a capital O, it means the loop is resilient against null values. If this is null, it will not delete the internet. That's what this construct means. Looks funny, I know. I was looking for the shortest way to express this without wasting any characters. Yeah. Philosophy bot is what the logic engine is called. But okay, let's get all the rules. Get unclear list. Rules. Bot dot something. Okay, let's look up the class. I forgot the API. I don't know what it wants us to do. Just call. Okay, that was easy. It just takes a string, which is the whole program. You could probably make this bot once and then clone it for each iteration or something. Or reset it. Or we'll do a lot of parsing over and over, but we don't care right now. Program equals rules plus join with empty lines, rules, and the grouping. Was that all? Is it that simple? Is that even possible? I think then you just do something like think, which hopefully does not run forever. Max rounds 1000, there's a limit, that's good. Think. And then you get deduced, facts deduced. Yep. We could put this even into a convenience function. That sounds sexy. Philosophy. I cannot spell philosophy every time. Deduce. Straight deduce. That's not very tough now. Direct deduce, quick. Quick deduce. Quick deduce. Oh, Jesus Christ. Quick, just quick. Perform thought on program. Growth plus facts and return deduced facts. And then we do this. And then we save. And then we call this philosophy quick program got this number of facts for grouping. Ah. How long is it gonna run? It tries 27 different inputs. Okay, it's a set It's a collection, not a set. And facts. No? Are you kidding me? I have to make a little function here. And facts. And facts. Fact. Fact, fact, fact. These are facts, ladies and gentlemen. Ladies and gentlemen. These are not claims, these are facts. These are facts.
These are facts.
Yes, no, what? That's correct. What is happening? Brackets are happening. Bad brackets. Okay, got 0 facts. That's amazing. Oh, but it's just one of those. Yes, sure, it's just the last. Printed. Nice. Okay, because the bot is very verbose. It prints all day long. No? Why does it print so much? Oh, are you kidding me? It's not even... There's no flag to stop it from printing all day? Yeah, we should have that though. Print. Anything like quiet? No. Anything like verbose? Yes, no. Anything like debug? We have that. Okay, transient, bool. Verbose or quiet? Print. Okay, we just replace this quickly. Let's print with if verbose. Print. Okay, let's go for it. Boom. Oh my god, some of these will just have to be print if print replace place. Okay. Oh, I should put a lot of print statements in there. Always want to see what's going on. Have a match. Print. Logic round. Yeah, this is also. We don't want to see anything actually if verbose is false. Alrighty. No. Print if. Print unless. Interesting. No, print if. What's my computer doing? Fan spinning up. OBS is busy, as it should be, I guess. 1.5 cores, that's quite a lot. Never mind. Bool if flag print and return the objects. That's really loud. Why is the fan so loud? It's an HP notebook. Shouldn't it have a good quiet fan? It's not usually that loud. Print if ages oh no, I didn't define, okay. Okay, I think that should be it. Nope. Now it has to work. Try again. All the 27 combinations. Aha. 0 facts, 0 facts, 0 facts. I mean, that was easy in the end. Oh yeah, maybe, yeah, let's see. Okay, some of these inputs just produce 0 results. No rules fire, because, for example, this whole long line is just, there's no rule that matches an unstructured long sentence like this one. The bogus sentences also don't produce anything, but there are a couple groupings that do produce facts. And how about we just make what's called a multiset? This is sort of histogram. We count how often each fact was deduced in all the runs. And we also want it case insensitive because I want everything case insensitive. Let's say always difficult to name variables. CL is short for collection. Facts I deduce. Hold on, this is we could say, I don't know. Yeah. Yeah, it doesn't matter. It will still print this here fact I deduced. Okay, add to the histogram. Add all the facts. And then I'm sure we have print multiset. Nope. Ha. See? Cool. I want a new line here. Print ASCII heading results. Okay. Interesting. So a clear winner is the fact George tried, which, if we recall the input, George tried, but you couldn't say it right way out, is true. Yeah. And these others, this one is very good, you didn't try very hard. Which is where we wanted to go, I think. So how do we filter out this good result from the rest? Maybe it doesn't matter, it's the same case again. These are all, if they don't make any sense, they will not fire anything afterwards. And they're basically just different amounts of grouping. They're not even wrong in any way. There's wrong grouping. This is wrong because you couldn't say he is not a thing that can try something. This is a wrong grouping. These two here are completely right. Just one has an additional bracket in here. So these are, in a very important sense, compatible, and they are both correct. There's nothing to criticize here. So yeah, this is pretty good actually. We should put this into a function. Stretch the legs and automate. Yeah, let's make it a function. Okay, this is wrong. Or it's not general enough, it's the parser ID. Okay. Try. Groupings. Oh no, groupings. To philosophy. But groupings to deduced facts. Uses rules in unclear list rules. Okay. Yep. You're so loud, computer. Computer, you are so loud.
Can't you tell you are so loud?
Computer, you are so loud.
Computers, you are so loud.
You have to be prepared for speech recognition. Just adding an oh.
You have to be prepared for speech recognition.
Just adding an S or removing an S, like tiny details, they will go wrong. Just computer or computers. Just, it sounds similar to too similar to distinguish. Okay, now I screwed up my clipboard. Doesn't matter. Print multi-set. Oh, that's making a nice new function. Print multi-set with heading. I love these short functions. Heading. Heading. This fan is a bit annoying. Nice and short. And it fails. Oh, wait, what? Yes, the same result in a shorter function call. Terry, are you proud yet? I'll ask him one day. Okay, so now we could add more patterns and some rules and start to parse this stuff. Then, as we have a longer list of patterns and rules, things will become slow. Then we have to make the patterns a bit smarter so that they by default not match any combination but prioritize the useful combinations. That's how the brain works too. The drain is clogged with hair. It has to be cleaned. Yeah. Let's do this one, even though it's a bit disgusting. Where's the parser? Oops. Top down. Let's try this. Let's try this first. The drain is clogged with hair. One pattern applies already. Let's, yeah. Okay, let's see. Clogged with something. The parser should reparse now. Not happy with that. Clogged with hair. Then we can make a rule, but there will be one little problem. Say the rule is clogged with something. We just simplify it. It's a simplification rule. Something that is clogged with something is, oh no, without the dollar, is obviously, oh, there's no edit button. That's nice. We need more buttons here. Never mind, clogged with X. This was the rule I wanted. It's just simplifying this. But currently these rules will not be applied because rules apply to top level things, which are statements. And this is something that appears inside of a statement somewhere. So we need a special kind of rule that is applied everywhere. We can try, but it's not gonna apply. There are no results right now. However, if we just put in this here, we should have a result. Yeah, the result is $clocked, which is bullshit. And the second one is this one, which is good. So we would need a new flag for applying rules inside of other inside of statements. Let's assume we have done this already, then we could arrive at this one here. Yeah, we have we'll have the same problem again. I want to get to the point that it understands that being clocked is being dirty, and it makes sense to clean something dirty. Let's try to get to that point and then done. Let's just make a rule to get around this is clocked. Something is clocked and it is dirty. That should work. Drain is dirty, see? What was the wording here? It has to be cleaned. Rules. Are you lost already? This is dirty. X has to be cleaned. And what we want is actually this. And so, because this also appears in the question, it has to be cleaned. It will match. So we can resolve this it and answer the question. Let's try again. The drain is dirty. Now we should have the drain has to be cleaned. And that's pretty much the answer to this question. Yeah, we still have some work cut out for us. But progress is good. Motivation is high. Things are aligning. Talk to you soon.